So welcome to this latest video 162 Maths, and in this video we'll be continuing with the series of going through some higher GCSE Maths questions with the focus of looking at some big mark questions. Now, as always, there'll be a copy of the questions that I go through in this video to download by click on the link in the description, which I strongly recommend you do to have an attempt at these questions just so you can see what your knowledge is like on the topics covered. Now, before we get started working through these big mark questions, it's really important that you have got quite a strong knowledge of each of these particular topics. Now, if you feel by looking at the topics that we're going to go over in this particular video as being a bit sketchy, you think, I'm not too sure, then I would strongly recommend going back and revising these topics. Now, I'll also include a link in the description below for the contents page of the channel where you can access lessons that go through these topics in greater detail. So let's get straight into question 1. So question 1 asks us to solve the simultaneous equation of 2x minus 5y equals 13 and 3x plus 4y equals 8. Now, for these questions, what you want to do is try and either the x is the same or the y is the same. And you can do that by multiplying everything in each of the equations respectively. And so it's entirely up to you which one you want to go for. Now, typically, more often than not, most students prefer to get the x's the same. So what you want to do is find a common multiple of 2 and 3, which is 6. So then to get 6x, if I multiply this first equation by 3 and the second equation by 2, that hopefully should give me the same coefficient of x for both equations. So that first equation, multiplying everything by 3, is going to be 6x minus 15y equals 3 times 13, which is 39. And then for the second equation, multiply everything by 2 this time. So we're going to end up with 6x plus 8y equals 16. Now from this, we just need to decide whether we multiply and divide. So our x's are the same, they're the same sign, so we subtract both the two equations. So 6x take away 6x is nothing, minus 15y take away 8y is going to give me minus 23y, and 39 take away 16 gives me 23. So therefore, if minus 23y equals 23, then that means that y must equal minus 1. Now that we know that y equals minus 1, and we'll just highlight that, we can then pick one of the equations. So I'm going to go for, using 2x minus 5y equals 13. We know that y equals minus 1. So what that therefore means is I can then work out what 5y is. So that's going to give me 5x minus 5 times minus 1 is going to give me positive 5. So that's going to be plus 5 equals 13. And then we take away the 5, which then becomes 8. So x equals 4. So there I've got my two values. So here, all I need to write in the values here is x equals 4 and y equals minus 1. Now moving on to question 2, it says a solid hemisphere has a radius of x and a solid cylinder has a radius of 3x and a height of x. It says that the total surface area of the sphere, and we've been given the formula of 4 pi r squared, where r is a radius. And the question is asking us to work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder, giving your answer in its simplest form, and we need to show our working out. Now for the surface area of the cylinder, it's the hemisphere. Let me just write that properly. So we've got the hemisphere plus one circle, and for the net of a cylinder, well, that's going to look something like this, where we've got two circles, which is pi r squared, and then for the dimensions of the rectangle, well, that's going to be the circumference, which is 2 pi r, and this is the height. So we know that the hemisphere formula is 4 pi r squared, but it's a hemisphere, so we need to divide that by 2, and for the circle it's pi r squared. So using this, what we can then do is work out what each of those expressions is going to look like. So if I take the hemisphere to begin with, now notice that whenever we see an r for the hemisphere, that's going to equal x, whereas an r for the cylinder, r equals 3x. So for the hemisphere, we're going to do 4 pi r squared over 2, which is the curved bit, plus the circle, which is pi r squared. Now again, we know that r equals x, and we also know that 4 divided by 2 is 2. So this is going to give me 4 pi r, which we don't need to write r, we write x instead. So that's going to be x squared plus pi, and rather than writing r, I'm going to write x, so it's going to be x squared. And if we simplify, collect all the like terms together, we end up with 3 pi x squared. I'm just going to pull a little bubble around that because that there is the total surface area of the hemisphere. We then move on to the surface area of the cylinder. Now that is 2 circles, which is pi r squared plus pi r squared, plus the area of the rectangle, which is 2 pi r times h. Now remember that we know that the radius is 3x and the height is x. So substituting those numbers in, what do I get? Well, I'm going to get pi, and I'm going to get 3x squared plus pi 3x squared plus 2 pi r. Instead of r, I'm going to write 3x. Instead of h, I'm going to write x. Now this looks awfully messy, so let's just neaten all of this up. So here I'm going to end up with this bit, which is going to give me 9x squared pi. This is going to give me exactly the same, which is 9x squared pi. And simplifying this bit here, I'm going to get 2 times 3, which is 6 pi. X times x, which is x squared, and I've got a pi. So collecting the like terms again, I end up with 24 pi x squared. And that there is the surface area, or the total surface area of the cylinder. Now the question's asked me to write the ratio between the two. So looking at this, the total surface area of the hemisphere is going to be running out of colours, so let's go for blue. So the ratio of the total hemisphere is 3 pi x squared, and the total surface area of the cylinder is 24 pi x squared. Now as you can see, we can start cancelling things out. So we've got pi on both sides. We've also got an x squared on both sides. So what does that leave us with? Well, it leaves us with 3 to 24, which then simplifies to give me 1 to 8. And so there is my ratio. Now for 3 marks, I can't think of a simpler way. I'm sure there is going to be a simpler way. But again, when it comes to GCSE marking, either the number of marks are either going to be given for how much work you need to show or how long it should take you to do it. So obviously I've had to explain it, but it should roughly take you about 3 minutes, in which you get 1 mark for working out the surface area of the hemisphere, 1 mark for the total surface area of the cylinder, and then 1 mark for simplifying down to 1 to 8. Moving on to the next question, it says that K, L and M are weights. Both of the scales balance exactly, and the question is asking is how many M weights are needed to balance 1 L weight. Now for this, basically what we're wanting is we only want L's and M's. So let me just make sure that's written a little bit. So we only want L's and M's. Now looking at the first scale, we know that 3K equals 4L. And looking at the second scale, we can see that 1K equals L plus 2M. So what we need to do is do some rearranging and some substitution. So here we want to get rid of the K's. So let's make K the subject. So here I get K equals 4/3 of L. And K is already the subject here. So if I substitute this into this, I then end up with 4/3 L equals 1L plus 2M. Now what I want to do is get L the subject. So if I take away this L to the other side, I'm then going to be left with 1/3 L equals 2M. Take the 3, multiply the 3 over to the other side, end up with L equals 6M. So how many M's need to balance 1 L? Well, I need 6. And so there is my final answer. So the answer then is going to be 6. Moving on to question 4, it says A equals root 2 and B equals root 18. Match each expression to its value. 1 is done for you. So if I just zoom out, here is our options. Now one thing I noticed straight away is that root 18 can be simplified. So root 18 is the same as root 9 times 2, root 2, which is 3 root 2. Now again, to make life easier, I will probably use b equals 3 root 2. So let's go for this one here. So looking at the next one, so here we've got a plus b. So that's going to be root 2 plus 3 root 2, which gives us 4 root 2. So this is going to be going to this one here. Then we look at AB. So AB, A is root 2, so that's root 2 times 3 root 2, in which we then end up with 3 root 4, which is the same as 3 times 2, which is 6. So that is going to go there. And then our final one, we've got b over a, which is 3 root 2 over root 2, in which the root 2's cancel. So we're just left with 3. So this needs to go to that one there. Moving on to question 4, it says write 0.13 recurring as a fraction in its simplest form. So again, for this, we make our decimal equal to 0. Then we need to use powers of 10 to make the same number of numbers after the decimal point. So here I start off with 10x, which shifts those numbers along. I then multiply it by 100x, so that gives me 13.3 recurring. Now, as you can see, with these two sets, I've got the same recurring pattern after the decimal point. So if I just take those two, so I've got 100x equals 13.3 recurring, 10x, which is 1.3 recurring, and I take the two equations away, so that's going to leave me with 90x. 13.3 recurring, take away 1.3 recurring, is going to leave me with 12. So then just make x a subject, so I've got 12 over 90, and all I then need to do is simplify this fraction, which then gives me 4 over 30, which can be simplified to 2 over 15. So our final answer is 2 over 15. Moving on to question 5, it says points P, Q and R, where R is 8, 22, form a triangle. PQ is a horizontal line with P on the y-axis. Angle PRQ is a right angle with a gradient of where the gradient of PR is 2, and the question is asking us to find the coordinates of Q. Now for this, there's a couple of things we need to do first. So the first thing I'm going to do is I'm going to find the equation of PR. Now it tells us that the gradient of PR is 2, tells us just there. So here we've got m equals 2. Now when it comes to the equation of a line, I'm a big stickler for using y minus y1. You could use y equals mx plus c, that's entirely up to you, but I much prefer using y minus y1 equals mx minus x1. So here I'm going to use the coordinates of P. So using the point of R, which is 8, 22. So this is my x1 value. This is my y1 value. So substituting numbers in, we get y minus 22 equals 2 lots of x minus 8. And if I expand the brackets, I get y minus 22 equals 2x minus 16. Add the 22, and I'm going to get y equals 2x plus 6. Now as you can see, that there is the equation of PR, and as you can see, that ends in a 6, so that means that this coordinate here is 6. So from this, what I've then established from that, because it's on a horizontal line, PQ is a horizontal line, that means Q is going to have an x ordinate of x but a y ordinate of 6. So then what I then need to do is I then need to find, we know that the equation or the line PQ, or PR shall I say, oops, move it up. So the line PR is perpendicular to RQ, or QR I should say. So that means that QR gradient is going to be the negative reciprocal of the gradient of PR. So that means it's going to be minus a half. Now I know the coordinate of RQ, so the next thing for me left to do is to then find the equation of QR. Now we know that m is going to be minus a half. I know that r is 8/22. So I can then find the equation of this line. So again, using the same formula, I've got my minus 22 equals minus a half x minus 8. Simplifying it, expanding the brackets, end up with y minus 22 equals minus a half x plus 4. Taking the 22 over the other side, I get y equals minus a half x plus 26. Now at Q, y equals 6. So to find x, what I need to do is just make the equation equal to 6. So 6 equals minus a half x plus 26. Take the 26 over, end up with minus 20 equals minus a half x. Take the 2 over to the other side and I end up with x equals 40. So now I've got my coordinate of Q, which has got an x ordinate of 40 and a y ordinate of 6. Now moving on to our last question, it says show that 4 sine 30 minus tan 45 all divided by 2 cos 30 can be written as tan x, where x is an acute angle. So for these particular exact values of trig, if we try and write down what the actual exact values of trig for the trig ratios you can see in the question. So sine 30 is equal to a half, tan 45 is equal to 1, and cos 30 is equal to root 3 over 2. So substituting these values into the fraction we've been given, I'm going to get 4 lots of a half minus 1 all divided by 2 times root 3 over 2. Now simplifying this, 4 times a half is just 2 minus 1. The 2's cancel out, so I'm just left with root 3, which then leaves me solving the numerator. 2 take away 1 is 1, root 3. So here you should be able to spot that what exact values of trig for tan gives you 1 over root 3, well it's going to be tan 30. And there we go.